From our previous work with trig functions, we know the term SOHCAHTOA tells us that the sine of an angle is the opposite leg over the hypotenuse. The cosine of an angle is the adjacent leg over hypotenuse, and the tangent is the opposite leg over the adjacent leg. So for this 30-degree angle here, the sine of 30 degrees would be opposite over hypotenuse, so it's going to be 1 over 2. Cosine is adjacent over hypotenuse, so it's square root of 3 over 2. And tangent is opposite over adjacent, so it is 1 over square root of 3, which does simplify to square root of 3 over 3. Now let's use our calculator to find these exact same angle measurements. So first we want to type in the sine of 30 degrees. First of all, we need to make sure our calculator is in degree mode. This calculator is not, so I will use the down arrows. Go into degree, enter. Now I can quit out of that. And we want to find the sine of 30 degrees. And it's 0.5. So sine of 30 degrees is 0.5. Right? Cosine of 30 degrees. Cosine 30 degrees. We'll call it 0.866 for round off. The tangent of 30 degrees is 0.577. Now, what do you notice about these values of sine? 1/2 and 0.5 are equal. Okay. What about the cosine of 30 degrees? Square root of 3 over 2 and 0.866. Let's see if they're equal or not. So I'm going to do square root of 3 divided by 2 in my calculator. Square root of 3. Divide that by 2. That's 0.866. So they match up. And the same thing for square root of 3 over 3 should be 0.577. Let's confirm it. Square root of 3 divided by 3. 0.577. So two different ways of finding the trig values for the 30 degrees. Okay, let's use that to set up trig equations and help us solve for missing links in a triangle. So in this triangle, first thing I want to do is I want to figure out what the value of x is. Right? So let's look at the angle that we do know, 25 degrees. Let's use that to label the different sides of the opposite, adjacent, and the hypotenuse sides of the triangle. So this is my angle here. The opposite leg would be this leg. X is going to be the adjacent leg, and 8 is going to be the hypotenuse. So which trig function do we know that deals with adjacent and hypotenuse? Because we know this, the hypotenuse is exactly it. We're looking for the adjacent, so that tells us which trig function to use. Well, based on the term SOHCAHTOA, we want to use the one that deals with adjacent and hypotenuse. So we're going to use cosine. So here's our equation. Cosine of 25 degrees is the adjacent leg, which is x, and the hypotenuse is 8. So now multiplying each side by 8 gives us this next equation. And now to solve for x, I'm just going to type that value in my calculator, 8 times cosine of 25. 8 cosine of 25. Again, just make sure we're in degree mode, which we already were. And we'll round off at 7.25. So 7.25 is approximately what the length of x is. Alright, now to find y. I want to find the length of y. Now, I don't want to use the adjacent in that hypotenuse. I want to use the opposite in hypotenuse. So that would be sine for this one. So the sine of 25 degrees will be equal to the opposite value y over the hypotenuse value, which is 8. And again, multiplying each side by 8 will give us 8 times the sine of 25 degrees equal y. So let's type in 8 sine of 25. 8 sine of 25. 3.38. 3.38 is the approximate value of y. Okay, so that's how you use trig functions to find missing side lengths in a triangle. There are ways you can find missing angle measurements using trig functions. You can use what's called an inverse trig function. So here's an example. The sine of some angle is equal to a half. You want to figure out what angle that is. So here's how you write this in inverse notation. X is going to be equal to the inverse sine of a half. So going back to this original equation, the way you read that is the angle whose sine is a half. So that's what the inverse sine of a half means, the angle whose sine is a half. So all you have to do is type that into your calculator. In order to do inverse sine, you have to do second sine. You're going to do a half. You do 0.5, 0.1 divided by 2, doesn't matter. And you get 30 degrees. So x is 30 degrees. Now, if you recall from our previous slides, we knew that the sine of 30 degrees was a half way back from the first slide. So just check our answer and it's correct. Alright, so let's use this triangle that we want to solve for x here. So let's label the sides of our triangle. This is our angle we're dealing with. Obviously, this is going to be our hypotenuse. The 4 is going to be the opposite leg, and the 3 is going to be the adjacent leg. So which trig function, since we know that the 4 and the 3, we know the lengths of the opposite and adjacent, which trig function deals with opposite and adjacent? Know the term SOHCAHTOA. So which one has O and A? That would be tangent. Tangent is opposite and adjacent. So the way we're going to write our equation is the tangent of our angle, which is x degrees, is the opposite leg over the adjacent leg. And anytime you have the variable for the angle, you do the inverse trig function. So x is going to be the inverse tangent of 4/3. Because remember, the way you read this equation is x is equal to the angle whose tangent is 4/3. So we type that in our calculator. Inverse tangent of 4/3 is the second tangent. 4 divided by 3. And you get your angle to be approximately 53.13 degrees. So let me change this to approximately 53.13